Hi, pre-calc and trig friends. I want to talk to you today about something that could really help you with your trig identities because it seems to be a sticking point for many of you, and it's something that's coming up a good bit. And that is finding or noticing and recognizing expressions that could benefit from some factoring. Okay. Let me give you an example. And if you are in my fifth period class, we just worked this out a few minutes ago. Even if you're in my fifth period class, though, keep watching, because what I want you to do is I want you to understand what I did so that you can more likely see these. The situation here is that I need to recognize that that is a factorable expression. Not only is it factorable, it's a perfect square. It's a perfect square trinomial. That's what I'm going to treat it like, as a perfect square trinomial. Okay, so let's just look at that. We're going to come away from that and head back to it. Let's say I have x plus 3 squared. Well, that's x plus 3 times x plus 3. And that's going to give me x squared plus 3x plus 3x plus 9. Okay? Basically, what happens every time you square a binomial is you get the first term squared, my x squared, the last term squared, my 3 squared, and then twice, 2 times the product of these two things. In other words, 3 times x twice. Or if I do it in generic terms, I get a squared plus ab plus ba, which is the same thing. So I get 2ab plus b squared. This is the pattern anytime I square a trinomial. Square a binomial, which gives me a perfect square trinomial. Let's look at what happens when instead of a plus b, it's a plus 1, because these are the ones we keep bumping into. So that's even easier. Well, a squared plus 1a plus 1a, that's 2a, plus 1. What if it were a minus 1? Or let's say, what about x minus 1? X minus 1, x minus 1. See, we've got x squared, x times x is x squared. X times negative 1 is negative 1x. Negative 1x, again, gives me negative 2x. And negative 1 times negative 1 is positive 1. Okay? So seeing this pattern and knowing that, therefore, if I want to factor something that's in the form a squared plus 2 times a plus 1, I'm just going to get a plus 1, a plus 1. Or if I want to factor something that's in that form with a minus, x squared minus 2x plus 1, x minus 1, x minus 1, can help us recognize it when this is something, when the x that I'm squaring is something other than x. So let's look at what I mean by that. X squared minus 2x plus 1. What if, what if my x is 3a? Then we're talking about 9a squared minus 2 times 3a is 6a plus 1. So that factors as 3a minus 1, 3a minus 1. In other words, remember it factored as x minus 1 times x minus 1, which is like saying the thing I'm squaring minus 1 times itself. Here the thing I'm squaring is 3a. So 3a minus 1. If you multiply this out with FOIL, this is what you would get right here, which is another way of writing that. What if the thing that I'm squaring instead of 3a is x squared? X squared squared minus 2 times x squared plus 1. That's x to the 4th minus 2x squared plus 1. And that factors as x squared minus 1, x squared minus 1. That could actually keep going in terms of factoring, but I'm really just interested in getting it to that point for what we're looking at. Okay? This is the key one, but let's look at another one that's similar. How about if I were doing x cubed? X cubed squared minus 2 times x cubed plus 1. Well, that's x to the 6th minus 2x cubed plus 1. Notice that the exponent here is twice as big as the exponent here. Okay? Now, I'm about to rewrite this exactly what I have there with the parentheses, but I'm going to rewrite it just a little bit bigger because I'm going to fit something a little bit bigger in it. Okay? What if I put sine of x in there? And that's again plus 1. So then it's just sine squared of x minus 2 sine of x plus 1. And that's my x squared minus 2x plus 1 and factors as sine of x minus 1, sine of x minus 1. All right, I'm going to write it a little smaller now because you can't see it. Okay, let's suppose I don't want to do sine, I want to do sine squared. Sine squared of x. Sine squared of x. So this would be sine squared of x, sine squared of x squared is sine to the 4th of x minus 2 sine squared of x plus 1. And again, it's something squared minus 2 times that something plus 1, and so it factors as the something minus 1, something minus 1. So it's sine of x squared, the thing is squared minus 1, the thing that's squared minus 1. And I could use my Pythagorean identity, cosine squared plus sine squared equals 1, to simplify this a little. The one that we encountered was cosecant to the 4th of x minus 2 cosecant squared of x plus 1. So this is something squared minus 2 times that something plus 1. And my something is cosecant squared. So again, it's going to factor whatever squared minus 1 times whatever squared minus 1. And the whatever squared is cosecant squared. Recognizing this pattern can help you out a lot. Okay? In number 43 in our textbook, once we have factored it, then we can use the Pythagorean identity that says 1 plus cotan squared equals cosecant squared. So in other words, I'm going to come down here and cosecant squared minus 1. This is 1 plus cotan squared. 1 minus 1 just gives me just the plain cotan squared. So this is cotan squared, and this is cotan squared. And cotan squared times cotan squared is cotan to the 4th. And that is what I was asked to show. Okay, so recognizing that pattern can be a very, very helpful thing.